And this is the Particles Homework Booklet, question 30. And the question is, when a monochromatic light is shone on a clean cadmium surface, electrons with a range of kinetic energies up to a maximum of that value are released. The work function of cadmium is 4.07 electron volts. First thing to notice here that's screaming at me is they're being mean and they're mixing up the units between joules for the kinetic energy and work functions in electron volts. So what's the question asking to start with? State what's meant by the work function. It's the minimum energy needed to remove the electron from the material, from the metal, from the cadmium, whatever you want to put at the end there. So the minimum energy to do that job. Secondly, then, we've got to explain why the emitted electrons have got a range of kinetic energies up to a maximum value. So really, this is digging at the very heart of your understanding what's going on in the photoelectric effect. And a really useful place to start is to focus on the fact that the photon energy, the energy the photon's coming in with, depends on its frequency. And since we were given a set frequency for all of these, that means that is constant. We've got a one-to-one interaction between the photons and the electrons, so it's the energy that an electron gains can only be gained from one photon, which means that the maximum energy that the electron can end up with as the kinetic energy can be the energy from that one photon less the work function. And why is it a range up to a maximum of that? Because we'll need additional energy to remove any electrons that are deeper within the metal. Now, one thing that's useful to say here is I don't want to hear anything about energy levels there. The energy levels are essentially about isolated atoms and aren't relevant to the situation where we're looking at a metal and we're looking at free conduction electrons in the metal. Not of interest here. We're asked to calculate the frequency of the light, given your answer to an approximate number of significant figures. Now, we're not given that, but what we are given is Ek max and the work function. We're given Ek max and the work function. So that should be crying out to you, HF equals phi plus Ek max. H, known value. F is what we're trying to find out. Phi is the work function. We were given in electron volts, we need it in joules, so there's a 4.02 in electron volts, multiplied by 1.6 times 10 to the minus 19, the elementary charge, in order to get that into joules, plus that maximum kinetic energy we were given. If you do all the calculations, you end up with a frequency of 1.04 times 10 to the 15 Hertz. Depending on your rounding, they accepted 1.03 as well. That's 3 marks, and then the 4th mark was a standalone significant figure answer. Give your answers to an appropriate number of significant figures. The data from the data sheet, the work function in electron volts, that actually on the data sheet is to 3 significant figures. I should have given it written it as 3 significant figures there. And that maximum kinetic energy, we've got 3 significant figures everywhere. We're safe to give our answers to 3 significant figures. B, then, in order to explain the photoelectric effect, the wave model of electromagnetic radiation was replaced by a photon model. Explain what must happen in order for an existing scientific theory or model to be modified or replaced by a new theory. So there are 2 ways you can look at this. You can talk about the new theory making predictions which are tested, and here's the key part for either of these answers. That testing is done by other scientists, and or those results are peer reviewed. So it's never just one group of scientists turning the situation around. Alternative way of doing that is if you find the new evidence, that new evidence which has been found, which led to the new theory, that should be repeatable, and that can be checked again by other scientists, or it is peer reviewed. So in each case, it's the idea of something which is test or at least testable, and that is checked or tested by other scientists through a process which would include peer review. So that is the homework, the Particles Homework Booklet, question 30.